For most of modern astronomy, Uranus had a strange talent. It could sit in plain sight and still escape attention. Jupiter looked violent. Saturn looked majestic. Neptune looked feral. Uranus looked like a pale blue sphere with almost nothing to say. If you saw a simple visible light image of it, you could be forgiven for thinking this was the quietest giant planet in the solar system, a frozen world so far from the sun that it had simply gone numb. That impression hardened after Voyager 2 rushed past the planet in 1986. The spacecraft gave humanity its only close encounter with Uranus, and what came back seemed underwhelming at first glance. The disk looked smooth. The atmosphere looked muted. There were no giant storms advertising themselves to the camera. Compared with Jupiter's belts, Saturn's rings, or Neptune's dark systems, Uranus seemed almost emotionally absent. But that calm was always suspicious. Scientists knew even then that the visible image could not be the whole story. Uranus was too large, too cold, too chemically complex, and too physically distorted to be as simple as it looked. The silence was probably not proof of inactivity. It was proof that we were looking at the wrong wavelengths, at the wrong moment in its seasons, from far too far away. That is why the James Webb Space Telescope matters so much here. Webb did not merely give us a prettier picture of Uranus. It forced a correction in how the planet is imagined. In infrared, the world begins to stop behaving like a bland blue marble and starts behaving like what it really is: a tilted, frozen, chemically strange, seasonally extreme ice giant. With rings, moons, haze, clouds, and a history of violence written all through the system. When Webb looked at Uranus, features hidden by the visible light disguise became easier to read. The ring system stood out with far more clarity. Cloud structure became more meaningful. Brightness differences near the poles carried seasonal implications that a casual visible light portrait could never communicate. Instead of one flat emotional note, Uranus suddenly had layers. It had mood. It had weather signatures. It had geometry that felt wrong in a revealing way. And that is what makes Uranus so unsettling. It is not terrifying because it is noisy. It is terrifying because it is misleading. Many dangerous places announce themselves with violence. Uranus does the opposite. It offers you a soft color, a clean outline, a sense of stillness. Then every deeper measurement starts telling you that the stillness is cosmetic. The first reason is its tilt. Most planets in the solar system rotate like imperfect tops. Uranus does not. Its spin axis is tipped by about 98 degrees, which means the planet is essentially lying on its side as it travels around the sun. It does not simply lean, it rolls. That one fact transforms almost every other fact about the planet. Once you picture Uranus rolling through its orbit, ordinary planetary intuition begins to fail. On Earth, seasons are variations within a familiar cycle. On Uranus, seasons can dominate the entire experience of a hemisphere. One pole can spend decades facing toward the sun, while the opposite pole sinks into darkness for a comparable stretch of time. This is not winter in any human sense. It is climate stretched across a lifetime. Imagine a planet where the sky itself becomes a slow-moving geological event. Imagine being born into darkness so long that sunlight would feel like a rumor from another age. Imagine decades of dim cold with only distant stars and reflected light on the horizon. Then imagine the opposite hemisphere enduring an equally prolonged confrontation with a remote, weak sun that never behaves like the day-night rhythm your instincts were built for. This is part of why the source video's horror angle works. Uranus is frightening not because it has some mythical monster on its surface, but because the physical rules create a world that is psychologically hostile. the sky would be wrong, time would be wrong, weather would be slow in ways that make human patience irrelevant. Even orientation would feel wrong when you tried to understand what counts as up, what counts as season, and what counts as a normal day. Webb's observations sharpen that discomfort because infrared sees through some of the lies that visible light tells. In visible wavelengths, methane in the atmosphere helps give Uranus its cool blue-green appearance. That color is beautiful, but it is also deceptive. It smooths the planet. It hides contrast. It encourages the eye to settle too quickly. In infrared, however, the atmosphere begins to show texture, stratification, and energy flow. That matters because Uranus is not a frozen bowling ball. It is an ice giant, and even that term can mislead if you hear it too literally. It does not mean a world made of solid, familiar ice. It means a giant planet whose deep interior likely contains enormous quantities of water, ammonia, methane, and other volatile materials compressed into unfamiliar states. Above that interior sits an atmosphere dominated by hydrogen and helium, laced with methane, and shaped by temperature, chemistry, and pressure on scales almost impossible to visualize. The result is a planet that looks simple from a distance, but becomes increasingly alien the closer you think about it. There is no ordinary surface where you could stand and point. There is no clean boundary where atmosphere ends and solid ground begins. Pressure rises, temperatures change, chemistry shifts, and matter itself begins to behave in ways that do not map cleanly onto everyday experience. Uranus is less like a place and more like a layered process. And then the cold enters the story. Uranus has one of the coldest upper atmospheres in the solar system, with temperatures dropping to around -200 to 24 degrees Celsius. At nearly 3 billion kilometers from the Sun, the available sunlight is already weak and remote. But what makes Uranus even stranger is that it appears to emit surprisingly little internal heat compared with the other giant planets. Jupiter radiates more energy than it receives from the Sun. Saturn does too. Neptune, despite being farther away, still seems more internally active than Uranus in important ways. Uranus is the anomaly. It is as if some vital thermal engine inside the planet has been muted, buried, or disconnected from the outer layers we can observe. That is one of the most important scientific mysteries in the entire system. Why would a giant planet keep so much of itself hidden from thermal view? One major possibility leads back to the ancient violence that may have created the tilt in the first place. A catastrophic impact early in solar system history could have knocked Uranus onto its side and, at the same time, changed its internal structure enough to affect how heat moves outward. In that interpretation, Uranus is not just unusual, it is wounded. That idea is powerful because it connects the planet's sideways rotation, its strange heat behavior, and its overall sense of broken symmetry into one larger story. A giant collision would not simply tip the planet like a toy. It could reorganize layers, alter circulation, redistribute energy, and leave behind consequences still visible billions of years later. Uranus would become a planetary crime scene whose evidence was never cleaned up. Visible calm would then be the last thing you should trust. If anything, it would be the eerie stillness that follows a massive act of damage. That is why the phrase "calm blue disguise" fits so well. Uranus is the kind of world that can look peaceful while carrying the aftermath of one of the solar system's most extreme ancient events. Voyager 2 complicated the picture, but Webb complicates it even more. Voyager gave us the irreplaceable value of proximity. It saw the system up close, but it saw Uranus during a specific seasonal arrangement and through instruments that could not provide the same kind of infrared richness that modern astronomy can now reach. Webb does not replace Voyager. It exposes how partial our old reading was. When modern telescopes track Uranus, they do find clouds. They do find storms. They do find bright features that form, evolve, and vanish. The world is not motionless. It is subtle. Its atmosphere reveals itself on timescales and contrasts that require patience. That alone changes the emotional frame. The old boring planet turns into a planet that hides activity exceptionally well. That hidden activity becomes even more interesting when you think about the seasonal geometry. If one hemisphere receives decades of radically different illumination from the other, the atmosphere should respond. Temperature gradients should shift. Haze and circulation should change. Clouds should appear and disappear according to energy balances that make Earth-like expectations almost useless. On Uranus, weather is not merely meteorology. It is slow choreography between light, chemistry, and time. Infrared observations let you see more of that choreography. Bright polar structures are not just beautiful details, they are clues. Differences in reflected and emitted energy are clues. Ring visibility is a clue. Every new view adds weight to the idea that Uranus is dynamically alive in ways we still barely understand. It is not a dead sphere. It is a difficult sphere. And then there is the smell, at least in theory. The upper atmosphere of Uranus contains hydrogen sulfide. If you could somehow sample that air without instantly dying from pressure, cold, or other lethal conditions, you would encounter the unmistakable stink of rotten eggs. That detail is easy to turn into a joke, but it actually strengthens the deeper point. Uranus is not a serene blue ornament. It is a toxic atmospheric environment dressed in elegant colors. The chemistry keeps piling on. Methane shapes the visible appearance. Hydrogen and helium define much of the atmospheric bulk. Deeper down, water and ammonia help create a wholly different class of giant planet from Jupiter and Saturn. The layers do not invite simple interpretation. They invite models, indirect measurements, and argument. Uranus is a reminder that a beautiful image can conceal a badly understood machine. Its magnetic field only makes the machine stranger. On Earth, when you picture a magnetic field, you probably imagine something tidy enough to sketch in a textbook. Uranus refuses that elegance. The magnetic field is significantly tilted relative to the rotation axis and offset from the planet's center. That means the magnetosphere behaves in ways that are awkward, twisted, and difficult to simplify. Now combine that with the planet's sideways orientation. As Uranus rolls around the Sun, the magnetosphere does not simply sit there in a neat, stable arrangement. It tumbles and interacts with the solar wind in unusually complex ways. In plain language, even the invisible space around Uranus behaves like it was assembled from mismatched parts. If the atmosphere tells you the climate is strange, the magnetic field tells you the deep planet may be stranger still. Researchers have proposed that the odd geometry could reflect the way electrically conducting fluids move inside the planet. In other words, the magnetic weirdness may be another surface symptom of deeper structural weirdness. Once again, Uranus looks coherent from a distance and deeply off balance up close. The rings add a different kind of tension. Saturn's rings are theatrical. Uranus has no interest in that kind of beauty. Its rings are darker, narrower, and far easier to miss. They feel less like decoration and more like residue. When Webb shows them more clearly, the emotional effect is not grandeur, but unease. The system starts to look secretive, almost stealthy, as if the planet has been quietly carrying a sharp-edged architecture in the dark the whole time. Those rings matter scientifically because they record the history of collisions, particle behavior, gravitational shepherding, and the broader structure of the Uranian system. But they matter artistically too. They help correct the false emotional message of the smooth blue disk. Uranus is not soft. It is a ringed, fractured, chemically hostile giant world whose darkness simply happens to be understated. Then you reach the moons, and the system becomes even more compelling. Uranus has 27 known moons, and several of them feel like unresolved chapters in a much older story. Miranda is the obvious standout because its surface looks almost stitched together. Giant faults, mismatched terrains, and huge scar-like structures make it look less like an intact moon and more like a body that once suffered catastrophic disruption. Ariel is different. It appears brighter and in some areas geologically younger than some neighboring moons. That hints at resurfacing and internal processes that must have shaped its history. Umbriel looks darker and more ancient, as if it preserved a different memory of the system. Titania and Oberon are larger and carry their own records of impacts, tectonic features, and deep freeze. None of this feels ornamental. It feels forensic. The source video's instinct is right. The moons make Uranus feel like the center of a damaged family. The scars do not all tell the same story, but they all suggest that the Uranian system has lived through more violence and complexity than the planet's simple color would ever imply. Miranda, in particular, almost dares you to stop calling Uranus boring. There is another psychological twist here. Because Uranus is so far away and so visually understated, it has often been treated as a middle child between more visually dramatic giants. That neglect is part of the horror. One of the solar system's most structurally bizarre planets has received the least intimate attention. We have had one flyby. One. That is astonishing when you consider how much this planet could teach us. Planetary scientists increasingly see Uranus as a priority target for a future flagship mission. That interest is not romantic. It is rational. A dedicated orbiter and probe could transform our understanding of giant planet interiors, atmospheric circulation, seasonal evolution, magnetic dynamos, ring dynamics, and moon histories. It could also answer questions that reach far beyond our own solar system. Why beyond our solar system? Because ice giants may be among the most common kinds of planets in the galaxy. Many exoplanet surveys suggest that worlds in the broad mass and size range between Earth and the largest gas giants are common. If Uranus represents a major class of planets that the universe likes to build, then every mystery we leave unsolved there weakens our understanding of countless distant worlds. That means Uranus is not just a weird local curiosity. It may be one of the best laboratories we have for understanding a normal planetary outcome on a galactic scale. The irony is almost cruel. The planet that once looked the dullest may turn out to be one of the most important. James Webb's contribution fits directly into that larger scientific shift. Webb is not flying into orbit around Uranus. It is not replacing a probe. But it is changing the conversation. By revealing the planet with greater sensitivity in the infrared, it gives researchers better evidence, better context, and better urgency. It forces Uranus to stop being a blank placeholder in the public imagination. And that matters for storytelling, too. The strongest version of this documentary is not one that screams louder about terror. It is one that lets the real features carry the dread. 42-year darkness, a planet rolling on its side, hidden clouds inside a pale mask, a strangely weak heat signature, a displaced magnetic field, dark rings, broken moons, a single historic flyby, and then decades of absence. You do not need to invent horror when the structure is already there. Even the light itself feels emotionally wrong. On Uranus, sunlight is so weak that brightness would lose its earthly confidence. The sun would not dominate the sky with warmth and power. It would feel distant, diminished, almost symbolic. That changes everything about how you imagine the place. The cold is not just numerical, it is atmospheric in the psychological sense. Uranus feels like a world where energy has been rationed for billions of years. And still, the planet keeps secrets. We do not know its deep interior in the way we would like. We do not fully understand how heat transport works there. We do not fully understand the seasonal atmosphere. We do not fully understand all the ring dynamics, the moon histories, or the magnetic geometry. Uranus remains one of those rare worlds where each answer tends to enlarge the mystery instead of shrinking it. That is exactly why a return mission matters. A modern orbiter could watch the atmosphere over time instead of glimpsing it once. A descent probe could measure composition, temperature, pressure, and winds directly as it fell. Magnetometers could map the field in far greater detail. Cameras and spectrometers could track the rings and moons with a level of precision unimaginable in 1986. Uranus would stop being a half-read file. Until that happens, James Webb is doing something precious. It is peeling away excuses. It is removing the old comfort of saying Uranus looks boring, therefore perhaps it is boring. No. The new data says the quiet look was never the same thing as a quiet world. So when you look at Uranus now, do not stop at the color. Do not stop at the clean circle and the soft blue tone. Think about a planet that rolls. Think about hemispheres trapped in decades of wrong light. Think about a chemically hostile atmosphere, one of the coldest upper air layers in the solar system, and an interior that may still be carrying the trauma of an ancient impact. Think about rings so dark they almost vanish, moons that look shattered and reassembled, and a magnetic field that behaves like it forgot how symmetry is supposed to work. Think about how long we ignored all of that because the visible image looked calm enough to dismiss. That is the real effect of James Webb's view. It does not turn Uranus into a monster. It turns Uranus into itself. And that is more unsettling, because reality is harder to escape than fantasy. The horror is not that Uranus became strange. The horror is that it was always strange, and only now are we learning how much of that strangeness was hidden inside one of the most innocent-looking planets in the sky.